Hello friends, I'm Bob. In this video I will be showing you the solution to the integration of x sine inverse x dx. But before I do so, if you guys like the solution, help me press the thumbs up icon below this video. So for this particular question, we are going to first solve it by applying the integration by parts. The integration by parts formula tells us that if I were to let one of the term as u and the other term as dv, so this is equals to uv subtracting away the integral of v du, in which to find my v I will integrate dv, and to find my du I will differentiate u. So right now I let u be equals to sine inverse x and my dv to be equals to x. So differentiating u with respect to x, this gives me 1 over the square root of 1 minus x squared, in which multiplying both sides by dx I get du is equals to 1 over square root of 1 minus x squared dx. To find v, I will integrate x dx, so this is equals to x squared over 2. I now found my u, du, v and dv. I apply the integration by parts formula to move on to the next step, and I have the following. So my u is equals to sine inverse x, and then my v will be x squared over 2, subtracting away the integral of v, which is x squared over 2, and du is 1 over the square root of 1 minus x squared dx. I simplify the whole problem and it looks something like this, in which next I will need to evaluate what is the integral of x squared over square root of 1 minus x squared. For this particular part, we'll apply the integration by parts technique. Now we will split the integral into the following. We have the integral of x times x over square root of 1 minus x squared dx. I let u be equals to x and my dv be equals to the negative of x over square root of 1 minus x squared. So that means for this particular case, it will becomes the negative of x over square root 1 minus x squared, and then we have a positive sign here. For this particular part, this is the next step. So we let u be equals to x and dv be equals to negative x over square root 1 minus x squared. Find my du, I differentiate u with respect to x. It's just basically dx. And then for v, I will integrate dv, which is the integral of negative x over square root of 1 minus x squared dx. This gives us basically just square root of 1 minus x squared. I found my u, du, v, dv. I apply the integration by parts formula to move on to the next step. I will get the following. So for the first term, I will just copy as it is. And then as for the evaluation part, I will apply the integration by parts formula. So there will be u times square root of 1 minus x squared, subtracting away the integral of v, which is square root of 1 minus x squared. My du is just dx. The next part I have to do is I have to evaluate what is the integral of square root 1 minus x squared dx. For this particular part, we will actually apply the integration by substitution technique. We let x be equals to sine theta, in which if I were to differentiate x with respect to theta, I get cosine theta. Multiplying both sides by d theta, I get dx is equals to cosine theta d theta. We have the integral of square root 1 minus x squared dx. We substitute all the details inside, so we get the following: the integral of 1 minus sine squared theta. So my dx is cosine theta d theta, and I will get the integral of just cosine squared theta d theta. So the next step, I will apply the double angle formula of cosine squared theta. So we get 1 plus cosine 2 theta over 2 d theta, which can be split into the integral of half d theta plus the integral of cosine 2 theta over 2 d theta. This is equals to half theta plus sine 2 theta over 4. Plus c. And from here we get half theta plus half sine theta cosine theta plus c. The reason is because we apply the trigonometry identity that sine 2 theta is equal to 2 sine theta cosine theta, and hence the second term itself, it becomes just half sine theta cosine theta plus c. And last but not least, we have to switch all the details into x. So for the first term itself, half theta is just basically half sine inverse x. And then as for the second term, we have half sine theta is x. So how do I find my cosine theta? Well, I can draw a right angle triangle, and from the right angle triangle we have theta here, and my sine theta is equal to the opposite over hypotenuse, in which my opposite length is x. Then my hypotenuse length is 1, in which my adjacent length is just the square root of 1 minus x squared, in which my cosine theta is basically just adjacent over hypotenuse. My adjacent is square root of 1 minus x squared. Hypotenuse length is 1. So basically the integration of square root 1 minus x squared is just basically this particular part. Half sine inverse x plus half x square root 1 minus x squared plus c. And now we move on to the final part. So we get the following, which is equals to x squared over 2 sine inverse x plus half bracket x square root 1 minus x squared minus half sine inverse x. Then we have plus half x square root 1 minus x squared plus c. And then we simplify in the manner we should get the final answer, which is in orange, x squared over 2 sine inverse x minus 1/4 sine inverse x plus 1/4 x square root 1 minus x squared. This is the final answer in orange for the integration of x sine inverse x. It is x squared over 2 sine inverse x, subtracting away 1/4 sine inverse x plus 1/4 x squared root 1 minus x squared plus c. If you guys like the solution, press the thumbs up icon and do consider to subscribe for more integration problems. I'm Bob. Thank you guys for your support, and I'll see you in the next video. Goodbye guys.